Let's discuss tests of significance. Tests of significance are used to test the hypothesis, whether the hypothesis is true or false. It is expressed in terms of probability. So, we will discuss this session according to following learning objectives. First, we will study the introduction. Then, what are various types of tests of significance, where they are applied, because we know that there are two types of data, qualitative and quantitative. Some tests are applied on qualitative data and some are applied on quantitative data. In the end, we will summarize the session. So let's start. What are tests of significance? These are tests of significance are used to see whether there is difference between observed and estimated values. If this difference exists, whether this is by chance or it is expected. They see if the difference is statistically significant or not. Tests of significance are used to see the significant difference. Suppose there are two values, observed and estimated. We apply test of significance, then we will accept or reject null hypothesis on the basis of this test of significance in terms of probability, like p-value. Test is accepted or rejected on the basis of p-value. So there are few types of test of significance like standard error. Standard error is one type. Then there is t-test or student t-test. Then there is z-test and chi-square test. These are various types which are included in your syllabus. There are other types also. Standard error difference between two means. Standard error difference between two proportions. So we'll start from standard error. What is standard error? It is standard deviation of sampling distribution. Or we can say that standard deviation of sampling distribution is called standard error. We calculate standard error by standard deviation and sample size. You have to remember the formula that standard error is calculated by divide standard deviation with number of square root of number of observation. So we must know the sample size to calculate standard error. So sample size is necessary to calculate standard error plus standard deviation must be given. So you can calculate standard error. What are confidence limits? What is limit? Confidence limit is a range within all the possible sample mean. Our range within the sample mean is called confidence limit. We have set certain confidence limit like 1 standard deviation, 1.6 standard deviation, 2.58 standard deviation, and 3.29 standard deviation. 1 standard deviation is equal to 68%. Then 1.96 is equal to 95%. Usually in stats we take 95% confidence interval or confidence limit. And 2.58 is equal to 99%. 3.29 is equal to 99.9%. Most commonly used confidence limit is 95% confidence limit. Or you can remember roughly 1 standard deviation is equal to 68%, 2 standard deviation is equal to 95%, and 3 standard deviation is equal to 99%. An interval between these limits is called confidence interval. What is hypothesis? As we have discussed earlier, it's an assumption. There are two types of hypothesis, null hypothesis and alternative hypothesis. When we accept null hypothesis, we reject alternative hypothesis. If we reject hypothesis, then alternate hypothesis may be accepted. What null hypothesis state? We already discussed that there is no significant difference. Remember the word significant difference between two variables or two populations or two proportions. If the difference exists, it might be due to some error. When we reject, we can accept alternative hypothesis. Their use, null hypothesis is applied to see the test of significance. Null hypothesis is applied in chi-square test, in t-test. Either we accept it or we reject it. There are two types of error, type 1 error, which is also called alpha error, and type 2 error, which is called beta error. Simply remember, if null hypothesis is falsely rejected, this is called alpha error. Sometimes it is falsely accepted. This error is called beta error. Why it is falsely accepted or rejected? It might be a calculation error. While calculation, you make an error and null hypothesis is falsely rejected. It was true, but you reject it falsely. And when null hypothesis is false, but you accept it falsely, that is beta error. What is p-value? P-value is value of probability. P-value instead, standard p-value is taken as 0.05. This is standard value 0.05 and 95% confidence interval is taken. And if it exceeds from 0.05, you accept the hypothesis. If p-value is lesser than 0.05, you reject the null hypothesis. Basically, it's value of probability of acceptance. And if we take 99% confidence interval, we set p-value 0.01. But remember, this is a common MCQ. Usually we select 95% confidence interval and p-value, standard p-value taken is 0.05. Now we move to t-test. What is t-test? T-test is test of significance. It is also called student's t-test. Why student t-test? A student, William Sibley, invented this test and named it as student t-test. You must know three questions. What are prerequisites? Where t-test is applied, and what are types of t-test? You must know the application of t-test, types, and prerequisites. What are prerequisites? Sampling should be simple random. There should be simple random sampling. Data should be quantitative. There should be normal distribution. And you must know the sample size. Then we can apply t-tests. T-test is applied in a population with simple random sampling technique. Our sampling should be random. Data should be quantitative, like numerical data. There should be normal distribution, no skew distribution, and you have to know the sample size. There are two types of t-test, paired t-test and unpaired t-test. What is paired t-test? Paired t-test is applied if we make the comparison in one group. Remember, if comparison is done on one group, or we can say that before and after comparison in the same group, like hemoglobin level before and after pregnancy, or before and after, or before and during pregnancy, we will apply paired t-test. So you must know where it is applied. In university, they ask the questions. You have to see the hemoglobin level of female before pregnancy and after pregnancy. Which test of significance will you apply? Your first answer should be t-test. Then you must specify that this is paired t-test. Now, we will discuss unpaired t-test. Unpaired t-test is applied when comparison is made on two different groups, like male and female. You want to see hemoglobin level of male, or you want to compare hemoglobin level of male and hemoglobin level of female, you will apply unpaired t-test. So you must remember, question will be asked that you want to compare hemoglobin level of 100 males with hemoglobin level of 100 females. Which test of significance will you apply? Your first answer should be t-test. Then you must specify that is unpaired t-test. What is application? Let's assume they ask a question that you want to compare average weight, average weight of female before and during pregnancy. Which test of significance you will apply? You will apply paired t-test because comparison is made in the same group. This is before and after comparison. If they ask you want to compare average weight of male and female, you will apply unpaired t-test. And t-test is applied on quantitative data. You must remember this. Then we ask if p-value is 0.07 and p-value is 0.04. At 0.07, you will accept the null hypothesis is accepted, and at 0.04, it is rejected. Remember, 0.05 is standard value, p-value 0.05 or above 0.05. We will accept null hypothesis. If p-value is less than 0.05, we will reject null hypothesis. What is z-test? This test is also used in quantitative data, or also applied in quantitative data. And what is the difference between t-test and z-test? T-test is applied on two means, but if we want to compare means of three populations or more than three populations, we will apply z-test. So this is a quantitative test that is applied on means, but mean of three groups or more than three groups. Like we can say that we want to compare average hemoglobin of first year MBBS, second year MBBS, third year MBBS. We will apply z-test. You must know the sample size before application. Sample size should be known. Population mean should be known. So we will apply z-test. So we have discussed tests which are applied on quantitative data. They are t-test and z-test. Now we will move to qualitative data. Chi-square test. Chi-square is applied on qualitative data. We want to see quality, like which drug is superior. We compare two drugs. We compare two vaccines and want to see that which vaccine is superior. We will apply chi-square test. It is applied on case control studies. In case control study, we will apply chi-square test. So we draw a 2 by 2 table. Like in the given scenario, they have said that there 100 smokers were taken and 100 non-smokers were taken. Researcher want to see that lung cancer is common in smokers. While studying, it was found that 6 smokers developed lung cancer out of 100, and 4 non-smokers also developed lung cancer out of 100. So difference seems marginal, but results clearly show that smoking causes lung cancer. But only 6 smokers developed and only 4 non-smokers developed lung cancer. It seems marginal, so we will apply chi-square test. We will calculate the expected values. These are the observed values. We will calculate the expected values and then apply this formula. Summation O is observed value, E is expected value. Then we calculate it and we will find the degree of freedom and apply probability table. And results show that the difference is statistically significant because value of chi-square is greater than 4. Now let's take an example. Remember, standard value of chi-square is 3.84, which is equal to 0.05 of p-value. Chi-square value decreases and p-value decreases. There is inverse relationship between them. P tends to increase and chi-square tends to decrease, then we can say that null hypothesis is accepted. But if chi-square value increases, p value will decrease and null hypothesis is rejected. There are 4 steps to conduct or to apply a chi-square test. These are: number 1, application of null hypothesis. We will apply null hypothesis. We will calculate estimated values. Then we will apply x square value. Then we will apply degree of freedom. After application of degree of freedom, we will see probability table and compare chi-square value with p-value in the probability table. If p-value is greater than 0.05 or 0.05, we can say that there is no significant difference between two populations, between two vaccines, between two drugs. Let's take an example. Vaccine A is given to 90 individuals, 90 persons, and vaccine B is given to 86 persons. After taking vaccine A, 22 persons still developed the disease, and after injecting vaccine B, only 14 people developed the disease. First, we will draw or we will make 2 by 2 table. So there are 4 boxes. Here we write vaccine A and vaccine B. A was given to 90%, B was given to 86%. How many were attacked with disease and how many remained safe? As in the given data, 22 were attacked, so 68 were not attacked. While in vaccine B, 14 were attacked and 72 were not attacked. Attack rate, then we'll calculate the attack rate. Attack rate of vaccine A is 24.4%. And attack rate of vaccine B is 16.2%. Apparently, vaccine B is superior. It seems that vaccine B, if vaccine B is given, there are less chances of developing an infection or developing a disease. It is superior apparently. But whether vaccine A was given to immunocompromised, vaccine B was given to healthier persons. So we have to apply chi-square test in the above data to see whether this difference is statistically significant or not. Whether this difference is merely by chance, it can be due to by chance. As I have mentioned, that vaccine A can be given to immunocompromised people, so there are greater chances of developing the disease because their immunity is less. And vaccine B was given to healthier individuals, so there were lesser chances of developing the disease. So these are observed values: O1, O2, O3, O4. Now we will calculate the estimated values. We will draw another table and we will calculate estimated 1, estimated 2, estimated 3, estimated 4. This row, this is labeled as column C1, this is labeled as C2, this is labeled as R1, and this is labeled as R2. So now we will apply a formula and calculate the estimated value. The formula of calculation of E1 is, you must remember this formula, calculation of E1. E1 is part of C1 and R1. So we multiply C1 with R1 and divide it with total population. Then we will get the answer. Our answer is 18.40. So we will write 18.4 here. What is the formula of E2? E2 is part of C1, but R2. So we will multiply C1 with R2 and divide it with E. Our answer is 71.59. So we write 71.59. Then we will calculate E3. E3 is part of R1 and C2. This is part of R1 and C2. So C2 multiplied by R1 divided by total population, and our answer is 17.59. Then we'll calculate E4. E4 is part of R2 and C2. So we'll multiply C2 with R2 and divide it with E. Our answer is 68.4. What is C1? C1 is 90. C2 is 86. What is R1? We will add these two values. R1 is 36. What is R2? We will add these two values and we will get the answer 140. So to calculate E1, you will multiply C1 90 with R1 with 36 and divide it with total population. Our answer will be 18.4. While calculating E2, as we have mentioned that E2 is part of C1 and R2. So we'll multiply 90 with 140 and divide it with 176. Why 176? We'll add vaccine A and population of vaccine 2. So our answer is 176. That's how we calculate E1, E2, E3, and E4. After calculating E1, E2, E3, E4, we will apply scare value. The formula of chi-square is observed value minus estimated value. We'll take their square and divide it with E. As there are four O's, four observed values, and four estimated values, so we will write the formula O1 minus E1 divided by E1 plus O2 minus E2. We'll take their square and divide it with E2. Then we will add O3 minus E3 square plus O4 minus E4 divided by E4. We'll calculate them. We will put observed first, then we'll put estimated value E1, then we'll put observed 2 and subtract it with E2. Then we will add O3, E3 in the same way. and our answer is 1.79. Now, we will calculate the degree of freedom, which is the third step. Degree of freedom. Degree of freedom means freedom within a limited degree. Number of columns minus 1, number of rows minus 1. Answer is 1. In case of chi-square test and 2 by 2 table, degree of freedom is 1. Now we will see probability table. We will compare. We'll see probability table. Degree of freedom is 1 and chi-square value is 1.79. Our answer will be greater than 0.05, because as I have mentioned earlier that if chi-square value decreases from 3.84, p-value automatically increases. So we will accept the null hypothesis in this case. And what will be our interpretation? That there is no significant difference between A and vaccine B. Both vaccines have equal efficacy. The difference was due to some error. The difference was by chance. We will accept the null hypothesis. So, what is the application of chi-square test? It is applied on qualitative data. Sample size should be known. So, you can have a university question. They will give you the p-value, chi-square value, and ask the interpretation. Usually in exams, interpretation is asked. Calculations may be asked, but most important thing is where chi-square test is applied, why it is applied. So plus the formula and interpretation, null hypothesis is accepted or rejected. Because you see null hypothesis in test of significance, you accept it or you reject it. It is accepted or rejected. Now we'll summarize the session. We have discussed tests of significance in this session. You should know that which tests are applied on qualitative data and which are applied on quantitative data. For qualitative data, chi-square test is applied. For quantitative data, t-test and z-test are applied. T-tests have two types, paired and unpaired. Plus, t-test is applied where two means are compared, and z-test is applied where more than two means, 3, 4, 5 means are compared. Chi-square test, the standard value of chi is 3.84, which is equal to 0.05 of p-value. If it is greater than 3.84, null hypothesis is rejected. If it is lesser than 3.84, it is accepted. T-test, p-value 0.05. For quantitative data, you will apply, but if you compare before or if you do before and after comparison in same group, paired t-test is applied. But if you compare two different groups, unpaired t-test is applied. Like you want to compare average heights of male and female, then you will compare unpaired, then you will apply unpaired t-test. But if you want to compare hemoglobin of female before and after pregnancy, then you will apply paired t-test. Or you want to compare hypertension, blood pressure in the same group before and after intervention. You have given atenolol to this group. You will compare before blood pressure before atenolol and you will compare blood pressure after atenolol. You will apply paired t-test. You will remember, you have to remember these things. Plus, what are various types of tests of significance? They are asked in exam. Or what are various tests of significance like standard error, t-test, z-test, and chi-square test. To conduct a research study, when you will conduct a research study, you will apply various tests of significance to prove that difference exists or not. Either it is by chance, you have to calculate standard error, you have to calculate t-test in numerical data, in quantitative data, you will apply t-test. Then you can apply z-test and conduct case control study. Or for qualitative data, you will apply chi-square test. These tests of significance will prove that hypothesis, null hypothesis is right or wrong. You are seeing the application, you are seeing the difference, whether it exists or it doesn't exist. And you know that null hypothesis states that if the difference exists, it might be due to some sampling error. Because you conduct the study, you select a reference population, Then you take a sample by applying some sampling technique, and this sample represents the whole population. You will observe the sample, you make some intervention in the sample, then you will make your assessment and will do the follow-up. Then you will generalize these results to the whole population. So appropriate sampling is important. It's mandatory for uh, accurate results. That's why we apply these tests, because it's not possible that we take accurate samples. Sometimes sample size is smaller, sometimes it is larger, so it depends on the scenario, it depends on the situation. So we have concluded the test of significance, plus we have also discussed confidence interval and confidence limits. And confidence limits, what is confidence interval? Interval between two values is confidence interval. Limits, like one standard deviation, we have said one standard deviation is equal to 68%. 2 standard deviation is equal to 95%, and 3 standard deviation is equal to 99% confidence interval. Usually, we take 95% confidence interval, like in a given scenario, you are asked to calculate the range by this. You have given a mean, which is 220, and standard deviation is 10. You are asked to calculate range according to 95% confidence interval. How will you calculate? Simple formula is mean plus minus standard deviation. You know that for 95% confidence interval, standard deviation is 2. 2 standard deviation is equal to 95%. So we'll take the mean plus minus. We'll multiply the standard deviation with 10. So the answer will be 220 plus minus 20. Then our range will be from 200 to 240. Why it is between 200 to 240 plus, cause first we will subtract 20 from 220, then we will add 20 with 220. Our answer will be from 200 to 240. Usually if they ask, sometimes they can ask that calculate standard range according to 99% confidence interval. How it is calculated then? Mean plus minus standard deviation. Mean is 220. Standard deviation, 99% confidence interval has 3 standard deviations. So we'll multiply standard deviation with 3. Our answer will be 220 plus minus 30. This will be the range. They can also ask that calculate range according to 68% confidence interval. CI is confidence interval. Then answer is very simple, mean plus minus standard deviation. Mean is 220, standard deviation is 10. Our range will be from 210 to 230. Usually we can calculate from 1 standard deviation, we can calculate from 2 standard deviation, and we can calculate from 3 standard deviation. This is the example of calculating range from standard deviation. We can take another example, like if mean is 200, standard deviation is 20, and we are set to ask calculate range according to 68%, 95%, and 99% confidence interval. Mean according to 68% confidence interval will be, range will be mean plus minus standard deviation. Range is 200, standard deviation is 20. So our answer will be 180 to 220. Range is 180 to 220 according to 68% confidence interval. But for 95% confidence interval, we will multiply the standard deviation with 2. Mean plus minus 2 into standard deviation. Our answer will be mean is 200 plus minus 2 into standard deviation is 40. So our answer will be ranging from 160 to 240. So if we increasing confidence interval, range increases, value of range increases. For 99%, mean plus minus 3 standard deviation. Our answer will be mean is 200, standard deviation is 20. We'll multiply this with 3. So our range will be from 140 to 260. So as we are increasing confidence interval, range increases. You can see clearly that According to 68% confidence interval, range is different. According to 95% confidence interval, range is different. And according to 99% confidence interval, range is different. So we can calculate the range according to confidence interval, which is given. If they ask 95, you have to multiply standard deviation with 2. And if they ask calculate range according to 99% confidence interval, you have to multiply standard deviation with 3. And if they ask calculate range according to 68% confidence interval, you have to multiply standard deviation with 1. So that was today's topic. We have covered standard error, we have covered chi-square test, t-test, z-test, what are their types, what is their application, what is standard p-value, what standard p-value is set, what are various confidence intervals. That's all.